for the session, and so I guess we are good to go. So this is again section 2.6, graphing rational functions. Graphing rational functions. Right. So let me remind you. So last week we discussed, the notion of rational functions. We discussed the horizontal and vertical asymptote of rational functions. So let me just remind you very quickly the definitions. First, a rational function. So what's a rational function? So a rational function is a quotient of polynomials. So a rational function, f of x, is of the form. So f of x equal to p of x over q of x, where p and q are polynomials, right? So it's a quotient of polynomial functions, right? Where p and q are polynomials. Now, let me remind you the notion of vertical asymptote. Vertical asymptote. So a vertical a line. So the line x equal to a is a vertical asymptote. Okay, if when x goes to a plus or minus. So remind you, this arrow here means x approaches. So the arrow means that x approaches a, and the plus or minus means from the left or from the right. So the plus, that's from when x approaches a from the right, and the minus when x approaches a from the left. Okay, so what we are saying is that if x approaches a from the left or from the right, x is not equal to a, but x is as close as we want from a. Okay, then what happens to the values of the function f? Then f of x, the values of the function f, they're gonna go to the positive or negative infinity. Okay, so yeah, so if you prefer, we can, so we have the following picture. So what we are saying is that, so I have x equal to a, so somewhere here on the x-axis, this is the x-axis, of course, x-axis, this is the y-axis. So somewhere on my x-axis, I have x equal to a, and here's my line, x equal to a, vertical line. Okay, and what we are saying is that if x approaches a, so my x is very close to a, so here's my x. My x is in the, let's say in the blue interval, right? Very close to a, not equal to a, but very close to a. Then the corresponding values, of the function f. So what do I mean by the corresponding values of the function f? So, well, that's, so the blue interval, that's my x in my input x, right? So then the output f of x, the output f of x is close to positive infinity. So my output is gonna be close to, you see here, it's close, approaching positive infinity. So there's gonna be my graph of f of x. Okay. And this is my vertical asymptote, right? On the right side of a, so here's your x approaching a from the right side, and the values, the corresponding outputs. Well, let's say here's my corresponding outputs, is at, let's say, negative infinity. So here's my function f. Okay, so here's my function f of x. Okay, And again, what we are saying is that so here, so my graph, the graph of f of x, is as close as we want from the vertical asymptote from x equal to a. But of course, it doesn't touch. Okay, this is really, really important. So your graph doesn't touch. The graph of f of x doesn't touch the line, the vertical line, the vertical asymptote, right? It doesn't touch the vertical asymptote x equal to a. Okay, they're gonna be very close, but they don't intersect. Okay.
Can you go down? I can see what you wrote.
Oh, sorry. Sure. Is this better?
Yeah, thank you.
Okay. Sure. So that's the idea of the vertical asymptote, guys. Now, what about the horizontal asymptote? So let me remind you now the definition of the horizontal asymptote. Oh, well, before the horizontal asymptote, so we said, so how do we find, so to find the vertical asymptote, all we have to do is solve the denominator equal to 0, all right? That's how we find the vertical asymptote. Now, so that's for the vertical asymptote. Now, what about the horizontal asymptote? So the line y equals to L is a horizontal asymptote okay, when x goes to, so now x is gonna go to positive or negative infinity. So when x goes to positive or negative infinity, then f of x, the values of the function f, they're gonna approach L. Okay, so what I'm saying, guys, is that so this is supposed to be positive infinity. This is supposed to be my negative infinity. Let's say y equals to L. So here we are on the y-axis. This is my y-axis. So y equals to L. L is some number. So let's say this is my L. Okay. Y equals to L would be this horizontal line. This is y equals to L. Okay. Now, what we are saying is that so when your x is at positive or negative infinity, so let's say here's my x. So my x is here approaching a negative infinity, right? Here's my x. You see my x is approaching negative infinity. The output y, the value of the function f, all right? When x is close to negative infinity, the value of the function f, they are close to L. So here's the value, here's the value, the output, or the value of the function f. So it's very close to L. So the graph, my graph should be somewhere right here, okay? So you see my graph, it's very close to L. But of course, again, it doesn't touch, you know, the horizontal asymptote. So here, so they don't touch, right? Okay. And the same when x is at positive infinity. So here's my x somewhere here at positive infinity. Here's my x, and so the output, you know, the output y. So again, guys, here there are two options. Either you can be like below the horizontal asymptote or above the horizontal asymptote, right? So there are two options here. Either you can be somewhere here above the, just above the horizontal asymptote, so somewhere here close to L, right? So then your graph is gonna be right here, very close to the horizontal asymptote, but it's above the horizontal asymptote, right? And the other option is that your graph is below the horizontal asymptote. So it's still, here, both cases, your output, we see here in both cases, your output is going to be very close to L anyway. Okay. And of course, the graph doesn't touch the horizontal asymptote. Now, how do you find the horizontal asymptote? Well, just to remind you, so to find the horizontal asymptote, we have to compare the horizontal asymptote. We have to compare the degrees of the top. What I mean by degree is the degree is the highest power of x, right? So to compare the degrees of the top, degrees of the top and the bottom. So and the bottom. So last time we said there are like 3 cases. So when the degree of the top is larger than the degree on the bottom, or when the degree of the top is less than the degree of the bottom, or when they are equal. Okay, so we're gonna have like 3 cases, and that's how you determine your horizontal asymptote, right? Now, so today, this is just to remind you what we did very quickly, what we did the last week. So now let's graph. Let's have some explicit examples and graph our rational functions. So I'm going to show you how to use all these informations. So today, so we're going to graph. So first, so we need to find the vertical asymptote. Right? 2, we have to find the horizontal asymptote. 3, we have to find and plot, of course, the x-intercepts. 4, find the y-intercept, and we have to plot the y-intercept. And 5, of course, we're going to graph f of x. We're going to use all these informations to graph f of x. So I'm going to explain with an example how to use all these informations to graph f of x, right? So let's have an example. So let's say f of x is equal to, let's say x plus 3 times x minus 1 over x minus 2 times x plus 2. Right? So that's my rational function, right? It's a quotient of polynomials. Now, we have to find vertical asymptote. Okay, so find vertical asymptote. So we said we have to solve the bottom equal to 0. So that would be the x minus 2 times the x plus 2 equal to 0. And so, I mean, this is kind of, this is not really hard to solve because it's a product. So you see, guys, this is a product which is equal to 0. So when you have a product equal to 0, then one of the factors is 0. So either the x minus 2 is 0 or the x plus 2 is 0. All right, so this is x is equal to 2, and then here x is negative 2. Right, so so the answer for number 1, so we got 2, 2, vertical asymptote, x equal to positive 2, and x equal to negative 2. No, Kwame, we don't need to expand here. No need to expand because you want to solve the equation equal to 0, right? And I mean, in general, to solve an equation equal to 0, we have to factor, right? But this is already factored, right? So you don't have to expand. Okay, now number 2. Well, number 2, actually, we have to be careful with number 2. So okay, so number 2, we have to find the horizontal asymptote. Okay, and so how do you find this horizontal asymptote? So we have to compare the degrees of P of x and Q of x. So what's P of x? P of x, that's the top. So here's my P of x, that's the top, and the bottom here, that's my Q of x, right? So so my question for you guys, what's the degree of P of x? Any guess? What's the degree of the numerator? What's the highest power of x in the numerator? Yes, Kwame, very good. No, Leah, actually it's 2. It's not 1 because if you, so, your P of x is, so it's P of x, sorry, it's x plus 3 times x minus 1. So it's x plus 3 times x minus 1. So if you expand the P of x, if you distribute x times x, that will be x squared, minus x plus 3x minus 1. So actually the highest power of x is not 1, it's actually 2. Okay, so it's kind of like hidden in this factorization. So it's P of x, degree of P of x is 2. So degree of P of x is 2. That's the highest power of x, actually. Well, the same for Q of x, right? So Q of x is just it's x minus 2, I think, times x plus 2, and the same thing. So it's just x squared minus 2x plus 2 minus 4. Anyways, the highest power of x is 2, and so degree of p is equal to the degree of q. Oops. So the degree of P of x, come on, sorry. So the degree of P of x is equal to the degree of Q of x is equal to 2. So we are in the third case. So this is case number 3. And in the case number 3, we said the horizontal asymptote, y, would be the ratio. So then y would be the ratio of the leading coefficient. All right, so in other words, y, so the answer, so y equals 2. So what's the leading coefficient of P of x? It's 1, right? It's the leading coefficient, guys, that's the number in front of the highest power of x. So it's 1 times x squared. So my leading coefficient, is 1. Q of x, the leading coefficient is the same. It's 1. So then y would be 1 over 1. Okay. The leading coefficient of P. This is leading coefficient of P. And in the bottom, that's the leading coefficient of Q. Okay, so then that will be, of course, 1 over 1. That's equal to 1. And so that will be my horizontal, is the horizontal asymptote. Any question, guys? Well, you may ask, what are the other two cases? Well, we discussed this actually last week. So the first case, that's when the degree of P is larger than degree of Q. then in that case, actually, there will be no horizontal asymptote. The second case is when the degree of P is less than the degree of Q, then the y equals to 0 is going to be the horizontal asymptote. Okay, so now this is the third case when P and Q have the same degree. All right, any question, guys? Okay, none. So for number 3, the x-intercept.
Wait, sorry. So we're using 1y again?
Excuse me?
We're
Y?
using 1 over 1y?
Yes. So no, I mean the equation of the line is y equals to 1. So the
I'm
answer.
asking why.
Yes. Yeah. Y. Yeah.
No. I'm asking.
Oh, why?
Okay, how?
Sorry.
Sorry. WHY.
Yeah. No, because so horizontal asymptotes are like horizontal lines. Okay. So and the form of the equation of horizontal lines are is always the form like y equals to a number. Okay. So if you have a horizontal line, the form of the equation would be y equals to some number. All right.
Okay. But however, if there was, let's say, if there was a 2 for P, x, P of x equals 2x squared, and then Q of x equals 1x, 1x squared, would it be 2 over 1?
Yeah, absolutely. Okay. It would be 2 over 1, and that would be equal to 2. Yes, absolutely. All right. So yes, yeah. So 3 x-intercept. So the x-intercept we have to solve. We have to solve the top. That's P of x equal to 0. So we have to solve the P of x, which is x plus 3 times x minus 1. So that's the x plus 3 times x minus 1 equal to 0. Again, this is a product, equal to 0. So either the first factor is 0. So either the x plus 3 is 0, or the x minus 1 is 0. So we get -3 and +1, right? So then the answer, the x-intercepts, are so -3 and +1. Okay, so we got 2 x-intercepts. Last thing to do is to find the y-intercept. Y-intercept. So in the y-intercept, guys, just plug 0 in the function f. So we have to evaluate f of 0. So we're gonna just plug, f of x is x plus 3 times, and this is actually a common mistake. So just be careful, guys. I think this is times, right? This is multiplication. So x plus 3 times x minus 1 over the x minus 2 times the x plus 2. So if you plug 0, so let's see, 0 plus 3 times 0 minus 1 over the 0 minus 2 times the 0 plus 2. So that would be positive 3 times -1 over -2 times the positive 2. So, but that would be a -3 over -4. So that's a positive 3/4. Okay, 3 over 4. So then my y-intercept is 0 3/4. Right now, so now the last and the most important thing is how do we use all these informations to graph our function f. So now number 5. So so we're going to try to graph f of x.
Wait, if it's 3 times -1, wouldn't it be -3?
Yeah, but the bottom, the denominator is also negative, so it's negative.
Oh, I didn't even notice that. All right.
Sure. So x plus 3, x minus 1 over the x minus 2, x plus 2. All right, so here's my x-axis. My x-axis, this is my positive infinity, this is my negative infinity. Here's my y-axis. So first thing to do, guys, this is my y-axis. Y-axis. This is, of course, my x-axis. Okay, so first we start with the horizontal asymptote, right? So we said the horizontal asymptote is y equals to 1. So I'm going to draw the horizontal asymptote first. So let me just write it down here for you. So horizontal asymptote, we said it's y equals to 1. So here's my, I'm going to probably need 1 here. So 1 here, right? And my horizontal asymptote would be this line, right? It passes through y equals to 1, right? This is y equals to 1. So let me write it here, y equals to 1. Okay, that's my horizontal asymptote. Next.
Professor?
Yes.
So the y-intercept, right? Can you go back to there?
Yeah, sure.
So 3 times -1, that's -3.
Yes. But over
So
negative 4.
okay,
Yeah. I jumped, I guess, one step. Yes, you're. Yes. So I was saying, yeah, the vertical asymptote, right? So that's we said it's x equals to positive 2 and x equal to negative 2. So I'm gonna need positive 2. So this is 1. This is positive 2. Negative 1, let's say somewhere here. This is my negative 2. And so here's my vertical asymptote. This is x equal to negative 2. And here's my x equal to positive 2. Right? Now, I have to plot the x-intercept. So the x-intercept, we said it's negative 3 and positive 1. Negative 3 and positive 1. So that's somewhere here. This is so here's my negative 3. So this is my x-intercept at negative 3. And we have positive 1. Well, Samira, I the first step, I mean, I said first thing to do is just to draw this horizontal line, the horizontal asymptote. Okay, just draw the horizontal asymptote. Okay, and then you draw the vertical asymptote. Okay, and then plot the x-intercept and then the y-intercept. So the y-intercept, that's 3 over 4. So it's 0.75. So it's less than 1. So my 3 over 4, it's somewhere right here. Okay, so this is my 3 over 4. Okay, now I got my x, y-intercept, my horizontal and vertical asymptote. Okay, now, so I'm going to graph my function f. So you always start from the left. Okay, so whenever I want to graph any function, you always start from the left. So we start at negative infinity. So my x is supposed to be, you start from the left. So your x is supposed to be close to negative infinity. It's somewhere here, right? In this blue interval. So we said because the horizontal asymptote, y equals to 1, well, it's an asymptote because when x is at negative infinity, your x is at negative infinity, the value of the function f is going to be very close to your horizontal asymptote. So, so my graph f of x is supposed to be as close as I want from the horizontal asymptote. But the thing is, the problem is, we're going to have like we're gonna have two options. Either the graph is gonna be below the horizontal asymptote or above the horizontal asymptote, right? So there are two options here, guys. You need to keep in mind. So we have an asymptote. There are gonna be two options. Either you're gonna be your graph is gonna be below the horizontal asymptote or above the horizontal asymptote. Okay, so we have to figure out which one is the correct one. Okay, and I'm gonna explain in a minute which one is the correct one. The thing, guys, is that next, after this horizontal asymptote, I have an x-intercept. So I have to join, you see here, I have to join my x-intercept. So the thing is, if you start above the your horizontal asymptote and you want to join your x-intercept at -3, then you have to cross. You see here, I have to cross at some point of this horizontal asymptote, right? At the when you are close to infinity, let's say. So the thing is, I cannot remember, guys. We said at infinity, you cannot really touch your horizontal asymptote. So I cannot really touch my horizontal asymptote here. Okay. So then the correct graph would be, of course, this one here. So you have to start below the horizontal asymptote, not above the horizontal asymptote, because you have to join your x-intercept. But if you join your x-intercept, you will have to cross, your horizontal asymptote when you are close to infinity. So the correct thing to do is to start below the horizontal asymptote and then join your x-intercept. So the graph here above the horizontal asymptote is not the correct one. So do you see, guys, why we have to start below the horizontal asymptote? Okay, perfect. Okay, now I join my x-intercept. Oops. I join my x-intercept at -3. Okay, I'm here. Now, okay, next. So what do we have next? Next, we have a vertical asymptote. And if I have a vertical asymptote, my graph is gonna be very close, as close as I want from my vertical asymptote. So it's gonna be, again, we're gonna have two options, right? Either your graph is gonna be up here or down here, okay? Now, which one is gonna be the correct one? Well, if you decide to go up, if I decide to go up like this, well, there is a problem. First problem is that I'm gonna cross the x-axis, right? And if I'm cross the x-axis, it means that I'm gonna have an x-intercept, but I don't have an x-intercept here, right? There's no x-intercept. So I cannot really cross the x-axis. So you see, guys, I have to go all the way down. Okay, because if I go up, I will have to cross the x-axis, but then I don't have an x-intercept at that place, right? There's no x-intercept there, right? So then the right thing to do is to go all the way down, right? So this is not the correct option here, because again, I would have to cross the x-axis, and that would be an x-intercept, but I don't have an x-intercept there. So, all right, makes sense. Now, next, you're gonna start again from your vertical asymptote, and again, you're gonna have two options. Either you're gonna start up here, right, or down here, right? You're close to your vertical asymptote, okay? And of course, so we're gonna have two options. Now, next, I'm supposed to join, so what do you have next? We have this y-intercept. So I'm supposed to join this y-intercept, right? So here, or if you start down here, you're gonna go up and join this, this y-intercept. But if you go up and join your y-intercept, you have to, because it's a continuous graph, so you have to cross your x-axis. But here, I don't have an x-intercept. I cannot cross the x-axis at that place, right? Because I don't have an x-intercept there. So the right thing to do is to go down from here to the y-intercept. So here there is no. So this thing here is not the correct thing. So that's not the correct graph. Okay, so that's why I have to go down, and then of course next thing I have. Oops. Next thing is this. So this is of course the C4 here. So next thing is this. I have to join this x-intercept here at 1, right? I have to join this x-intercept at x equal to 1. But then, again, I'm going to have a vertical asymptote and the same thing. I'm going to have two options. Either you're going to have something down here or up here, okay? Now, which one is the correct one? Well, if you decide to go up, then you're going to have to cross the x-axis. Yes, Glenn, we have to go all the way. We have to go down. Absolutely, yeah. So here we have to go down. Otherwise, again, if you go up, you're gonna cross your. You see here the yellow point. You're gonna cross the x-axis, and that will be an x-intercept. But we don't have an x-intercept there, right? So, so yes, we have to go down. So I have to erase this here. Okay. Here. Oops. All right. Now, next, we are almost done. Again, there are two options. Either you start up here or down here, okay, in the bottom. And then next thing, you don't have an x-intercept, you have nothing, but you're gonna have your horizontal asymptote at infinity. So horizontal asymptote at infinity, so your graph is gonna be close to the horizontal asymptote at infinity. And so we're gonna have two options. So if you start from the bottom here and you go up, if you go up here, then of course you're gonna cross the x-axis. That will be an x-intercept, but there's no x-intercept, right? So we cannot cross the x-axis. So then the right thing to do is to start from the top and go down here, okay? So so you see this thing here is not the correct thing, because it's not the correct graph, because I would have to cross. You see, I would have to cross the x-axis, but I don't have an x-intercept, so that's not the right thing to do. Okay. And guys, if you are not sure about the correct graph, I mean, if you have like you are kind of confused and you are not sure about the correct graph, what you can do, you can you can take some random values and check if your graph is correct. So for example, here I can take let's say here this is x equals to 2, right? I can take, for example, x equal to 3 and see if the image of x equal to 3, if it's positive or negative. So for example, if you take, again, this x equal to 3 is just a random number. You can take any number, let's say after 2, just to check if your graph is in the correct place, okay? So for example, if you pick x equal to 3, so this is a random pick, for example, x equal to 3. So what will be f of 3? You plug 3 in the function f, and my function f is x plus 3. So that will be 3 plus 3, times 3 minus 1 over 3 plus 2 times 3 minus 2. So that will be equal to actually 6 times 2, that's 12. 12 over 6 times 1, 12 over 6. That will be equal to 2. So the image of 3 is 2. And that makes sense because, so this is x equal to 3. So the image is 2. right? So this is supposed to be 2, of course, here. Right, so my graph is correct. So you can pick like random numbers, to check if your graph is correct. But again, you have to use some, logical thinking. Use your x-intercept to, to graph your function f. Any question, guys?
Yes, can you repeat the last part, please? How do you?
Yeah, last part. Yeah. Okay. So I was saying, you mean about the picking numbers, random numbers? Yeah, I was just saying. Yes. I didn't hear you. Sorry.
Oh, yes. How do we pick
Oh, okay.
number in
Okay.
the graph?
So yeah. So I was saying, if you are not sure about your answer, like I'm not sure if my graph is supposed to be, in the bottom here, let's say here, or or this one. Okay, I'm not sure if my graph would be the one in the bottom or the one in the top. So what you can do, if you are not sure about your answer, you can pick a random number. So here, for example, I picked x equal to 3, right? I pick x equal to 3, and it turns out that f of 3 is equal to 2. So f of 3 is equal to positive 2, but positive 2 is above the horizontal asymptote. So my x equal to 3, it's is equal to positive 2, right? So my graph cannot be the one in the bottom, because the output, or the output when x is equal to 3 is positive 2. So it should be above the horizontal asymptote, not below the horizontal asymptote, right? My horizontal asymptote is at level or a height 1, right? So f of 3, for example, is 2. So it's supposed to be above the horizontal asymptote, not below the horizontal asymptote, right? So then the graph, the one below the horizontal asymptote, is not the correct one, because you see f of 3 is positive 2, which is above the horizontal asymptote. You see my point? So yeah, you can sometimes pick just random, random numbers, just to make sure that your graph is correct, if you're not sure about your answer. Okay, perfect, guys. So all right, so here's an exercise, a similar exercise, so you can practice graphing rational functions. So what I'm gonna do, I'm gonna move to, if there's no question, of course, I'm gonna move to the next page. So here's an exercise. Okay, so let's say f of x is equal to, so let's say it's 2 times x minus 4 times x, let's see, minus 4 x plus 2 over x minus, let's see, minus 1 times x plus 1. All right. So first, please find vertical asymptote. 2, find the horizontal asymptote. 3, find the x-intercept. 4, find the y-intercept. And 5, graph f of x. All right. Okay, guys. So let's say you have like 10 minutes to think about this exercise and to graph the function f. Yes, Kwame, of course, you can get 3x intercepts. Yeah, sure. But I mean, here actually you don't have three x intercept. You're gonna also have 2x intercepts. Yes, Samira, very good. Yes, that's a vertical asymptote. Yes. By the way, guys, November 25th, you know, the day before Thanksgiving, Wednesday, actually follow, is gonna follow Friday schedule. So we won't have a class on November 25th. So actually, I think there are like probably five lectures left. that's I mean, times really goes fast, but I mean, yes, it's like probably it's like 5 lectures, 6 lectures left with the test. Number 2 on December 7th. Yeah, and after the test, we're gonna have probably a review. So December 9th, there will be a review for the final. And of course, I would probably also go over the test number 2. So yeah. The exam number 2. Yeah, I was saying, so the test number 2 is gonna be on December 7th. December 7th. And the final, that's actually on December 16th, okay, at 2 p.m. I will post the dates on Blackboard anyway. Yeah, but the second test on December 7th. That's a Monday. So the last day of classes, guys, it's December 9th. Okay, that's the last day of classes, December 9th. So this semester is kind of shorter, I would say, by a week than the usual time. So I mean, there are like 2 chapters left, chapter 3, chapter 4. Chapter 3 is about logarithmic and exponential. So we're gonna have probably 2 lectures about the chapter 3 because they are really important. I mean, exponential and logarithmic functions. And we have also 2 lectures about the trig. I mean, chapter 4, that's the trig. That's trig functions. Oh yeah, because yeah, the last day of classes is the 9th, but the final week is the final week starts at, I think, Friday 11th. So yeah, I mean the final week is different from the final week is the week after the last day of classes. Yeah, so last day of classes, that's is so December 9. And the yes. Yeah, the examination period is from December 14 to December 20. Okay, guys. I guess you are done with the exercise. Did you succeed? The graph of f of x. All right, so probably you are done, I guess. So let me at least start with the number 1. So for the vertical asymptote, we said we have to solve the denominator equal to 0. So we have to solve this x minus 1 times this x plus 2 equal to 0. And so then your x is going to be equal to positive 1 or x equal to negative 1, right? So vertical asymptote are x positive or negative 1, right? Now, for the horizontal asymptote, so just be careful here. The horizontal asymptote, so for the horizontal asymptote, so the top, the p of x, which is 2 times, x minus 4 times x plus 2, 2 times x minus 4 times x plus 2. So when you expand p of x, so you're gonna have, so distribute, so you're gonna have actually 2x squared, plus, etc., right? And for q of x, you're gonna have, so q of x is the x minus 1 times x plus 1. So q of x is minus 1 times x plus 1. So q of x, you're gonna have x squared, minus x plus x minus 1, right? So the degrees are equal. The degree of p of x is 2. The degree of q of x is also 2. Okay, so then degrees. So the degree of p of x is equal to the degree of q of x is equal to 2, right? So we have to take, so the answer here, we have to take the ratio of the leading coefficients, right? So, but then be careful here. So the leading coefficient of p of x is actually 2. Leading coefficient of q of x is 1, right? So then the answer, so y equals to 2 over 1, which is of course equal to 2, is the horizontal asymptote. Okay. The x-intercepts. So for the x-intercepts, we have to solve the numerator, which is the top, equal to 0. So we have to solve 2 times x minus 4 times the x plus 2 equal to 0, right? But then, so this is a product equal to 0. Well, of course, here we have a product of 2 with the x minus 4 with the x plus 2. So either, actually, you can say, well, either 2 is equal, this first factor here is equal to 0, but that's impossible, right? This is 2 is not equal to 0, so that's impossible, right? Or x minus 4 is equal to 0, but then your x would be positive 4, or your x plus 2 is 0, and so your x is negative 2. So so yeah, then the answer, of course, is so the x-intercept are so 4 and negative 2, right? Last thing. Before the graph, so we have to find the y-intercept. Okay, so the y-intercept So we have to plug 0, the function f. So it's 2 times 0 minus 4 times 0 plus 2 over 0 minus 1 times 0 plus 1. So the top would be 2 times negative 4 times positive 2. And in the bottom, that's negative 1 times positive 1. So then f of 0, negative over negative, that will be positive, and that will be 16 over 1, which is, of course, 16. So this the answer, y-intercept is 0, 16. Okay. Again, it's we have negative over negative, that's positive. This negative here over negative, that will be positive. Okay, so now last step. Okay, now the most important step, I would say, is to graph f of x, which is again 2 times x minus 4 x plus 2 over x minus 1 over times x plus 1, right? So that's my f of x. So let's see. Okay, so first I'm gonna draw the horizontal asymptote, which is a y equals to 2. So somewhere here we're gonna have y equals to 2. So this is 1, this is 2, and so here's my y equals to 2. That's my horizontal asymptote. Next, I need my vertical asymptote. That's x equal to 1 and x equal to negative 1. So let's say this is negative 1, this is positive 1, and here's my vertical asymptote. So this is x. So this is x equal to 1, and this is x equal to negative 1, right? Now, we have to plot the x-intercepts. So x-intercepts, we have positive 4. So 1, 2, so this is 1, 2, 3, and 4. This is positive infinity. Of course, this is negative infinity right here. So positive 4, and we're gonna need negative 2. So here's my negative 2. All right, so I have two x-intercepts at positive 4 and negative 2. And finally, the y-intercept, we said it's 0, 16. So somewhere here in the top. So let's say this is my 16, right? So this is my y-intercept. Okay, so now we are ready to graph a function f. You always start from the left. Okay. So you start from the left. When you start from the left, it means that your x is at close to negative infinity, right? When you start from the left, your x is close to negative infinity. And because y equals to 2 is a horizontal asymptote, then when x is close to negative infinity, your graph is going to be as close as you want from y equals to 2. And then again, we're going to have two options. Either your graph is going to be below the horizontal asymptote or above the horizontal asymptote. Okay, but then we have you have this x-intercept at negative 2. So there are two options here. Either you're gonna go from above the horizontal asymptote and then join this x-intercept, but then it means that like at negative infinity you're gonna cross your horizontal asymptote. And you're not allowed to when you are like negative infinity in the neighborhood of negative infinity, you are not allowed to cross your horizontal asymptote, right? The other option, of course, is just to go from below the horizontal asymptote and then join your x-intercept, right? So then, of course, so then the right thing to do is to start from below the horizontal asymptote, right? So this is not correct. Okay, and so here's my graph. Okay. Now, so you join your x-intercept, and then the next thing after my x-intercept at -2, I have my vertical asymptote. So my graph is gonna be again close to my vertical asymptote. So either gonna be up here or down here. Okay. Now the question is, I have to. So if you go up, well, then you're gonna cross the x-intercept. I mean, you're gonna cross the x-axis, and you're gonna have an x-intercept. But we don't have an x-intercept there, right? So you cannot really go up. Okay, so the option left is to go all the way down. So we have to go, all the way down here. Okay. Again, it's because if you go up, you're going to cross the x-axis, but you don't have an x-intercept. You're not supposed to intersect the x-axis again, right? After -2. Right after -2, of course. So this is, so I have to, I guess, erase this here. All right. Now, next, well, again, I'm going to start from my vertical asymptote, and I'm going to have two options. So let me just put this. So let's say this is longer than here. So here's my graph. So as I said, so there are two options. Either you're gonna start in the top here, okay, or in the bottom here. But then the next thing you have is this y-intercept at +16, right? So if you go up, if you go up from the bottom, you go up and you go to your 16, to your y-intercept, then it means you're gonna cross the x-axis. But again, you don't have an x-intercept, so you cannot really cross the x-axis. So you cannot really start from the bottom. So you have to go down like this here. Right? You have to go down like this and join our 16. Y-intercept at y equals to 16, right? So this is, I have to, so this is wrong here, because otherwise I would have to cross the x-axis. Now, next, after my y-intercept at +16, well, we're gonna have a vertical asymptote, and again, you're gonna have two options. Either you're gonna be up here or down here. Well, if you go down, from 16, you go all the way down here. Again, you're gonna cross the x-axis, right? But we don't have an x-intercept there, so that's not the right thing to do. So we have to go up. So we have to go up here, right? Because if you go down, you're gonna cross the x-axis, but you don't have an x-intercept there. So this is not correct. Right. Next, I'm gonna start again from this vertical asymptote. We are close. Our graph is very close to our vertical asymptote, so it's gonna be in the bottom here, or it's gonna be up here, right? But then you have to join your. There's an x-intercept at 4. Right, and then there's your at positive infinity. There's your, there's your horizontal asymptote. Okay, so the thing, guys, if you go down if you go down to 4, okay, and then you have to, go to your horizontal asymptote, either here or here. But anyway, you're gonna have to cross your x-axis. okay? And you also have to cross your horizontal asymptote when you're close to infinity, right? So you cannot cross the x-axis right here after 4 because there is no x-intercept after 4, okay? So anyway, so yeah, so you have to start from the bottom, go all the way up to 4, all right? And then from 4, again, there are two options. So from 4, either you can go, so you can go below the, below the horizontal asymptote or above the horizontal asymptote. But if you go below, above the horizontal asymptote, you're gonna cross the horizontal asymptote when you're close to infinity. And you are not supposed to touch or intersect the, your horizontal asymptote when you are close to infinity. Okay, so so the right thing to do is to go below the horizontal asymptote. So this is the right thing to do here. Okay, and so I have to erase this. Okay, so that will be the graph of f of x. So this is, of course, I have to erase this, of course. Okay, so any question, guys? Yeah, I mean, and again, guys, if you're not sure about something, then you can just pick a random value and check if your graph makes sense. For example, I can check. I can take, for example, I can pick a random value somewhere. Let's say here at 0. I'm not sure if my graph is, is in the right place. I can pick a random number. For example, here at 5. So for example, if you pick x equal to 5, you plug 5 in your function f. So let's see. Let's check our graph. So if x is 5, then f of 5, that would be 2 times 5 minus 4 times 5 plus 2 over 5 minus 1, 5 plus 1, right? So that'll be 2 times 1 times 7 over 4 times 6. So that'll be 14 over 24. All right. So anyway, so this 14 over 24 is less. It's less than 1, right? So what I'm saying is f of 5 should be less than 1, right? So you see here, this is 5. So f of 5 is, it's less than 1. And it makes sense because I'm supposed to be below the horizontal asymptote, which is y equals to 2. So I am below the height y equals to 2, right? So then my graph is correct, right? Because if you choose to go from the top here all the way down, so then f of 5, f of 5 would be somewhere here, which is higher than 2. Okay, but f of 5 is actually less than 1, so it's supposed to be below the horizontal asymptote y equals to 2. So this thing here is not, of course, that's not correct here. That's not my f of x here, right? So again, here's my f of x. Any question, guys? Yeah, I mean, you have to use like some kind of like a logical thinking here, and use your x-intercept. And be careful if you don't have an x-intercept. So you're not supposed to cross your x-axis. That's the main. I would say that's the main idea. And also, when you are close to positive or negative infinity, you are not supposed to cross your horizontal asymptote. Okay. But however, guys, just if you are not close to positive or negative infinity, so for example, you are somewhere here in the middle, okay, here in the middle, yes, you are allowed to, you can cross the horizontal asymptote, that's not a problem. But the thing is, when you are close to positive or negative infinity, so when you are like somewhere here, all right, or here, then you are not allowed to cross your horizontal asymptote, okay? But here in the middle, yes, you can cross the horizontal asymptote, that's not a problem. Okay, so here it's okay to cross the horizontal asymptote, but if you are here in a neighborhood of infinity, negative infinity or positive infinity, then you are not supposed to cross your horizontal asymptote, okay? All right, so, okay, so how much time do we have? We have like 20 minutes.
Professor,
Yes.
Can you please repeat when we can cross the horizontal asymptote?
Yeah, I was saying you can cross the horizontal asymptote if you are like, you are not close to negative infinity. So you see here's negative infinity, right? And this is, and here's, oops. And here, here's my positive infinity, right? So what I'm saying is that if you are, close enough to positive infinity and negative infinity, somewhere here, then it's okay. Then you cannot cross the horizontal asymptote, right? So I cannot cross this horizontal asymptote here, okay, or here at negative infinity, okay. So when you are close enough to negative infinity or positive infinity, you are not supposed to cross the horizontal asymptote. But if you are like somewhere in the between, like in the middle here, somewhere here, okay, here it's fine. You can cross the horizontal asymptote. That's not a problem. All right. Does it make sense? Yes, yeah, we can do it. That's actually my that's what I was thinking. Yeah. So yeah, let's do another example.
Can you do one when we can cross in the middle?
Yes. Okay. Perfect. That's what I'm gonna do. So okay, here's another exercise then. Exercise. Okay. So this is. Let me see. Okay. Well, so then let's say f of x is okay. So it's let's say x minus 2 times x. Let's see, minus 1 over x plus the times. Okay, this is positive. Okay, and here x, let's say x is actually minus 4. Okay. So same questions. So find the vertical asymptote, to find the horizontal asymptote, 3, find the x-intercept, find the y-intercept, and then 5, graph f of x. All right, guys. So you have, let's say, 10 minutes to graph, to think about this exercise, to graph function f of x. So sorry, here should be x plus 1. Oh yeah, by the way, guys, you will have a review sheet before the second test, okay? Probably we won't have a review before the second test because we'll have a review, before the final on December 9th. But we won't have, I don't think we're going to have a review before the second test because, we have like 4 or 5 lectures left before the second test. And we have to cover like I have to cover like 2 chapters. Okay, so but of course, you can, if you have any question about the review sheet, you can just email me. All right. All right, guys. I mean, we have like just 5 minutes. So I'm gonna try to go over the exercise. I'm gonna probably jump the some steps here because we don't have much time. So I'm gonna probably rush with the answers here. So for number 1, the vertical asymptote. So we have to solve the bottom equal to 0. And so if you solve the bottom equal to 0, you're going to have x equal to negative. So the answer here for number 1 should be -3 and +4. All right, so that's for that's a vertical asymptote. For number 2, the horizontal asymptote, if you expand the top and the bottom, they have degree, they have the same degrees. So degree of p of x of the top is equal to the degree of the bottom, and the bottom here, so it's equal to 2, and so the horizontal asymptote, is going to be y equals to, so if you expand, you're going to have 1x squared plus etc. over 1x squared plus etc. Right? So then the leading coefficient of the top would be 1, and the leading coefficient of the bottom would be 1. So it's 1 over 1, so it's equal to 1. So that's my my horizontal asymptote, right? So then the x-intercept. Okay, so we have to solve the numerator equal to 0, and so the answer should be so the numerator, that's the minus 2, so that's x equal to 2 and x equal to -1. So that's x equal to 2 and -1. Okay, so that's the x-intercepts, and finally for the y-intercept, you plug 0 on the function f of 0, so it should be -2 times +1. That's -2 in the top, so that's -2 in the top over, and in the bottom should be 3 times -4. That's -12. Right, so that's -12. Negative over negative is positive, and you reduce your fraction, so that's 1 over 6. All right, so now what about the graph? Okay, so this is now the graph. So we're gonna have, so this is my positive infinity, negative infinity. I'm gonna draw the horizontal asymptote, which is y equals to 1. So here's y equals to 1. This is 1 here. So y equals to 1. And then we're gonna have vertical asymptote. So vertical asymptote, we said our vertical asymptote, -3 and +4. So we're gonna need -3 and +4. So -1, -2. So this is -3. So here's my x equal to -3. That's my first vertical asymptote. Second vertical asymptote is at +4. This is +4. So this is x equal to +4. And finally, I'm going to plot the x-intercepts and the y-intercept, x-intercept. So we said that it's 2 and -1. So here's 2, and here's -1. And finally, my y-intercept is 1 over 6. So it's somewhere right here. Okay, so first, you start at negative infinity. So basically, there are two options here below the x-intercept. So you're going to have something like this here, all right, or above below the horizontal asymptote, right, or above the horizontal asymptote, right? And the thing is, if you take the one in the below the horizontal asymptote, then you're gonna have to cross the x-axis, but you don't have an x-intercept there, right? So then the right graph would be the one above the horizontal asymptote. Okay, so that's the right graph. Now, okay, so that's I'm gonna erase this. And then next, of course, you can start, oops, sorry. So you can start either in the top here or in the bottom here. Okay, so the thing is, if you start from the top and you go down to your next x-intercept, and then you're supposed to go to your y-intercept, but then you're gonna cross You see here, you're gonna cross your x-axis. So, and we don't have an x-intercept there. So you have to go up from here. Let me just erase this thing here. This is not correct because again, you're gonna have an, x-intercept. And so we have to go up, right? And then to my x-intercept, and then join my y-intercept. So we can imagine, guys, here, probably this is not a good example, but if my, y-intercept was like here, right? Then I would have to, I would have to cross my horizontal asymptote here, right, in the middle, right? So I would have to go to my y-intercept anyway. So I would have to cross the horizontal asymptote, right? If I had like a y-intercept here. So yeah, but that's not the case. My my y-intercept is just right here. It's the 1/6, and so then I'm gonna go to my next x-intercept, and then of course I'm gonna have two options. But the one we would have to go down, because if you go up, then you're going to have another x-intercept, but you don't have an x-intercept there. So you will have to go down, all the way down here, right? And finally, last part of the graph. So we're going to have, of course, two options, either going up to your horizontal asymptote or going down to your horizontal asymptote. But if you go up to your horizontal asymptote, then you're going to cross the x-axis, but there is no x-intercept there. So so the correct graph would be the one above the horizontal asymptote. All right. So that's of course. So this would be the graph of f of x. Okay. Sorry, guys. I went over time. So thank you, everyone. I guess I will see you on Monday, and sorry, not Monday. I will see you on Wednesday, and on Wednesday, I guess we're gonna start a new section, right? Thank you, everyone.
Is the homework going up today?
No, you're gonna have homework on Thursday as usual.
Okay. Happy. Bye.
Bye, everyone. Thank you. See you next time. Take care.